Hey guys, this is the RX460 that's been in its own repair video, part 1, and also in the GPU repair guide that I made. So I thought I'd come back to this now. This has a problem in the logic circuitry. So I'll show you under the microscope what this is actually doing and where we got up to, okay? Let's just... okay, let's do it. So where we got up to with this one, if you didn't see the previous video, we'll just remind it. This buck regulator generates the PEX 1.8 volt supply, okay? And I have the PEX voltage. Obviously before that I have 1.8, which is generated here. I have that, and I have 12, 3.3 and 5. So we're getting okay so far as here, yeah? And then this should send an enable signal through the logic circuit. There's a few transistors on this side and there's more on the other side, okay? And that enable signal comes from pin 1 here in the corner, yeah, that pin, okay? And it goes to enable on here, which I'd have to look it back up, it's either pin 5 or 7. And what's happening is, I have an enable signal coming out of this. Sorry, I have a power good coming out of this, yeah. But I don't have an enable getting into here. And that's what should happen. But it's not going to be connected directly. It's going to go via some sort of logic circuit. And on the back of the board here, there are some more transistors. So I noticed that this one was twisted badly to one side. And when I tested it, I thought this was faulty, because I couldn't see the base emitter and base collector, effectively diode junctions, although they're transistor junctions, but they look like diode junctions, yeah, to a multimeter. So I took that off and I checked it out of circuit and declared it to be faulty, and ordered some more, but I was wrong. And let me just show you why I was wrong. This is the data sheet, and at a glance, I didn't have it zoomed in as far as this. I just thought base emitter collector, okay, and I could see a base emitter junction. I only tested one side, but I couldn't see a base collector junction, and the reason being, when you look closely, this collector is part of transistor A, if you like, yeah, and this is transistor B, so the layout is not how I immediately assumed it was, and that's why I got it wrong. So I've now had a look at the part I took off, and it's fine. The reason it's this way round, I've come to the decision, is that because the layout's this way, it doesn't actually matter which way you put the device on the board, yeah? It doesn't matter, you can put it either way round and it effectively give you the same, yeah? But I put mine back on the same way as originally was. I looked on the previous video and had a look, and I've actually put it on the same way. So that's basically how far we've got with this so far, yeah? And I've also straightened it up. It was badly bent to one side. I don't know if it was a short, I don't believe there was. But now I've put the part back on, the first thing let's do is to test this again and see if it now actually works. Okay, so I've just put it in the motherboard for now. I haven't bothered with the box I normally balance things on so I can work on them. I just want to see if it actually now actually detects, yeah? Let's see. Something's not plugged in, power's not switched on the power supply. It's a little bit of just pad there, just to keep it a little bit cool. Okay, let's have a listen. No, it's still not detecting. Okay, so what we're going to have to do now is to trace through the logic circuitry to see where the problem is. So let's just remind ourselves of what we had last time. Yeah, I found a schematic for an MSI board. This is an MSI board, but not the same model as this one. Yeah, it's the other RX470, 480, and so on. But I was taking the assumption it's likely that both the schematic I have and this card are probably similar. Yeah, so let's have a look to see what I actually found. So this is the schematic, and this chip, this is the one that generates the PEX supply, yeah? And we can see the power OK is on pin 1. Now this shows this as an input, but it's actually an output, yeah? This is a pull-up resistor going to 5 volts, and in fact we do have 5 volts a period on here. So obviously the power OK goes high. If it was active low, there'd be a line over the word POK here, yeah, but there's no line, so that means it's an active high. And this does go high, yeah, and it generates a signal here called 0.8V P-good, yeah. If you watch the GPU how to repair video, this will all be familiar to you, yeah. If not, go watch it. I think it's a good video. A lot of people like that one. Okay, so we're interested in this signal, yeah, and we want to know how that gets to the other chip, the one that generates the voltage for the RAM, MVDD, yeah. So we can search for this signal, and we can just see where it appears on our board. It's probably easier if I just zoom it out a little bit while I do this, and we should be able to see where that appears on our board. Yeah, it appears here, power good, yeah, and this is going to something else, yeah. So we're not, that's the GPU, I think, actually, yeah. GPIO it says, yeah. Anyway, I'm not bothered about it. It's not what we're interested in. Okay. So where else does it go to? This is where it came from. Again, it's found that again. Maybe I clicked on the wrong arrow. And it appears here. P-good here. Yeah, let's zoom back in again now. This looks more like what we want to find. So here's the 0.8 volt P-good, yeah? And it goes to a transistor and another transistor. This is A and B. See, 1604, Q1604A, Q1604B. This is why I thought I had a faulty dual transistor, which I don't have, yeah? The component ID Q1604 doesn't match my board, but this is not a schematic for my board, so that's not unusual. But we can see it comes in here through 2 transistors and comes back out as this signal, MVDD comp, and this is the one, if I just search it for you, that goes to the other controller, the one that's getting no enable. So we'd expect high to be coming in here, yeah? This goes high, switches the transistor on, the base, this turns on, so the voltage here goes low, yeah? This turns off, and this should go high. There must be a pull-up resistor on here, otherwise it couldn't go high, yeah? Unless the enable pin pulls up itself. Let's have a look, yeah? MVDD comp. Okay, let's find that. Put it in, MVDD comp. If I can hit the control V. Doesn't want to work in this little box. Never mind. MVDD underscore comp. So that's what we were interested in, yeah? And you see that's coming out of here, yeah? So we want to see if that goes to our regulator, yeah? Find it on here somewhere. But yeah, it's probably easier if you zoom out a little bit while you're finding it. In fact, it is this one. So this is pin 7, which is the enable pin, yeah? I know it's this one because this part number actually matches the part number of our chip. Is it? No, it's not this one. This has more pins. This actually has 12 pins. Well, that's interesting. Maybe they use a different chip. Let's see if we go somewhere else. Goes here. No, just goes to here. And the signal where it comes from, yeah, from there. So this doesn't exactly match our chip, unless our chip happens to have underneath it. It's possible. We can see 8 pins on this chip, but it's quite possible all these are a pad underneath the chip, yeah. It matches in as much as we know we've got power coming on 5 and enable here. So let's just assume this is our chip, yeah. And this is pin 7. So we now need to trace to see what's wrong. We've got low here. And out of interest, I can't see the pull-up resistor either. Maybe this has internal pull-up. Okay, so let's have a look at our board and see if we can figure out where this signal is going, yeah? Okay, I am actually making the assumption that there might be some pads under here, because the part number does match our part number. It's also possible that the same chip effectively comes in a different package. Wouldn't be surprised. Anyway, let's not worry too much about that for now. Everything else seems to match what we have. So what I've done here, you can see I've tagged a bit of wire onto pin 7, which is the enable, and I've tagged a white bit of wire onto the resistor that goes to pin 1. This will be that pulp resistor we can see going to 5 volts. And the reason I've tagged these wires on, because the circuit, the logic circuit, is actually on the other side of the board. I had a quick look previously on another video to see if pin 1 here goes to either of these transistors around here, and it doesn't. So it's most likely it goes on the other side of the board. And now we need to find out where it goes. Now we could actually approach this from either end, if you see what I mean, from either the enable or the power grid. But I'm going to go from the enable. Just, there's no particular reason for that, it's just that's where I am going to go for, And underneath where that chip is, I can see some transistors, so it seems likely that these may be something to do with that signal. So let's get under the microscope and let's see if our green wire goes to either of these transistors. Okay, so I've got the meter on resistance mode, just normal continuity mode, not diode mode. There's no particularly easy way to do this sort of tracing. You can have a look to see if you can see where any circuit tracks are going. That's one thing you can do. And if we just go to the other side of this board, and I'll just get the focus for you. You probably can't see because of the I've soldered the green wire on. But I noticed before, and this was on the previous video, that this pin goes to a resistor, which I'm guessing is a pull-up, and it goes to like a wire that goes down through the board somewhere here. And if you want to, I'll link the other video, you can see that. But I know it goes down through the board to the other side. Okay, and on the other side, I know I have some transistors. So this is as good a place to start as any. I mean, we know these transistors are near to the chip, and we know the enable's coming through some transistors. It doesn't come directly from the power grid. So if we get onto the green wire, with fingers in the way, you can't even see. Bit of green wire. Let's just one end of the meter on green. I'm on continuity mode with resistance, not diode check. Just normal continuity mode. So what we need to do now is have a look to see if we can see this signal anywhere around here. I heard it. It's there. I heard it before I saw it. Yes, that's actually quite good, because that will be a collector of a transistor or the drain of a FET. I don't know if this is a transistor or a FET. I know this one's a bipolar transistor 1AM2, because I happen to know the part number and I can find the data sheet for that. I don't know what this RK and on its side Y is, but it's probably one of the other. In fact, we can even have a look. Let's see what it is. So go to diode mode. Let's have a quick look if it's a transistor. So if it's a transistor NPN, if we put the red on, I'm on diode mode now. If we put the red on, this would be the base. This would be the collector. And we don't get a bleep. Oh, do we get a bleep here? No, just go the other way. Oh, okay. It doesn't read the other way. Red like a, from what you think is the emitter to the collector, read like a beep backwards with a positive on the emitter. I'm sure this is a FET, and that's like a reverse polarized diode within the FET. So I'm pretty sure this is a FET. I could try and find it from the code, Type SMD code plus that and see what you find. If that doesn't help, but SMD code SOT23, which is a package in that code, and see if you can find anything. It should give you a part number, then you can look at the data sheets on the part number. But it's not that important. I'm pretty sure this is the output of this, and probably a gate. Sorry, probably a drain. So if that's the output, drain, I would say, because I'm pretty sure it's a FET. The input would be on the gate, and just the normal layout for these: base, collector, emitter, gate draw, gate drain source. So this is I'm pretty sure would be the input, and that, I think it looks like it comes from this transistor. Yeah, that comes from this one. Does it go to this resistor here as well? Yeah, which is probably a pull-up resistor, okay. And then this would be the input of this here, yeah? So let's draw this on a piece of paper now. So now we've got this little bit with it, and let's see if we can understand what we've got so far, okay? What we've got then is, which way shall I draw it? Normally, you have the source at this end and the, effectively like the input and output, yeah? That's how you normally draw a schematic. So we'll do it that way, yeah? So this is the MVDD, this is the controller for this one, yeah? And on pin 7 is the enable. And it's active high, so this needs to be high, yeah? That enable, we know, goes to a FET, yeah? And it looks like it goes to the drain of the FET. So let's draw our FET in here, yeah? Yeah. Gate, drain, source, yeah, and this is the one that says RKY. I don't know what it is, but what I could see here was a diode junction going that way, and that's what you find in a FET, yeah, an N-channel FET. So when I was reading this way, I could actually see that diode, yeah, and that's why I think I saw a diode junction one way. So I didn't bother to see where this one goes to, but my guess is this goes to ground, yeah. I haven't measured it, but that's my guess, that's where it goes to, maybe through a resistor, okay. There's another resistor on here, which again I didn't measure, but my guess is this goes to a positive voltage, yeah. VCC, whatever it is for this chip, yeah. So the gate then goes to this 1AM, which I know is a transistor, yeah. Like so. Okay. Again, the emitter, I haven't bothered to check it at the moment, but I'm pretty sure that this will go to ground, yeah? It makes sense it would go to ground, yeah? And it also makes sense that there's a resistor here up to VCC or some sort of positive, possibly the 5 volts, yes, I guess, 3.3 or 5, yeah? And then this heads off back, I'm assuming, towards our power good signal, yeah? So we've already got this bit of it, so without going and tracing this further back, which we might need to do, we can make some assumptions here. This is active high, yeah? So for this to be high, this must be switched off, yeah? This needs to be switched off. If this was switched on, it would short this point to ground effectively. So for this to be switched off, the gate should have 0 volts on it, or certainly a low voltage on it, yeah? For that to happen, this should be switched on, yeah? This needs to be switched on to short this point to ground, otherwise this would have 5 volts on, or 3.3 or whatever, yeah? So for this to be switched on, this needs to be high, and on the transistor, if there's no resistor in here, which there might be, this needs to be about 0.7 volts. It might be higher. If there was a resistor in here, which there could be, that would be higher, 3 volts, whatever, yeah? So we can trace around these two transistors now and see if that's what we find. If we don't find, if we find this is low, we need to go back further, yeah? If this is high, there's something wrong here. So let's get our voltmeter, let's power this thing up, and let's see what we've got in this area of the circuit. I've got everything connected up then, ready to go. Oops, let's just show you again. I've just added to this, this pull-up resistor. I had actually found this, you know, when I was measuring from the gate of here to the collector. I said, oh, it also goes to a resistor, and it's this one, R1099, and we can be sure this has got some voltage on 3 or 5. I think it would have to be at least 3.3 to turn this FET on, yeah, probably be a bit more than that, maybe 5. Okay, so that's what we're looking for, yeah. So let's start off, this should be high, but we know it's going to be low because we haven't got an enable, yeah? And let's just work our way back through here. By the way, I'll just mention something. This should be really obvious, yeah? But it isn't to a lot of people. When you're fault finding like this, when you're measuring voltages like this, and to be quite honest for that matter, when you're measuring resistances, yeah, you need to know what you're looking for. If you don't know what to expect, can I ask you, what's the point of measuring the voltage? Because whatever you find, it doesn't mean anything to you, yeah? If you don't know what to expect, then what you find has no meaning. Yeah? So you need to be methodical, like we've been here, like I'm hopefully like I'm teaching you here, how to be methodical. If you do your fault finding methodically, then that's when you're going to get results, yeah? Sorry, lecturing you all again, never mind. I'm sure a lot of you know this anyway. Okay, so let's just connect the power lead and let's power this up and let's see what we get compared with what we expect to find. Right, we're ready to power it up. Power's on. And we should hear this bleep when it doesn't detect, yeah? So, let's go to ground. There's the bleep, yeah? First place, let's go to the what we think is the drain of this, yeah? Now, this, I'm guessing, is going to be low because, yeah, because I've got no enable. And there we are, it's low, yeah? So that would suggest this FET is turned on. So if we go to the gate, it has 12 volts on it. That is seriously on, yeah? I'm guessing there's a resistor on the... That's more than a bit on. That would mean this transistor is off. Yes, it's off because it's floating high, and that was assume this is low. And this is low, yeah. That's the one coming in. That's the base coming in. That needs to be high, so we need to trace this further back. I'm a little bit surprised at that 12 volts, by the way, but never mind. The emitter of this will probably be 0, going to ground. Yeah, that's ground. The source of this, that's ground, yeah. And that's what 12 surprises me. Thought it'd be 5. Okay, so we need to know why that's low. So we now need to trace our circuit back a little bit further. This transistor then, the base should be high and it's not, yeah, and this goes, looks like it comes this way. Oh, thought it might go to there. We're bleeping. Right, it does go to there. No? Let me look through the microscope. I'll just get a good contact on this. I think it does go here. No, it doesn't go there. Does it go here? No. Oh, it does actually go to the here. Yeah, I've got it. Yeah, okay. So we know the base of this transistor disappears back through the board, yeah? We can now take the green wire off here because it seems to come back through under here somewhere, probably one of these, yeah? And we don't need this anymore because we know where this goes to on the other side of the board. So what I'm going to do now is take this wire off and tag it onto the base of our transistor because we want to follow back from there, yeah? So let's move the wire to there, then come back onto this side of the board and let's see if we can see where it actually goes to. Okay, so there's our bit of wire tagged on there now. I find this method the easiest to tag a bit of wire on when you go from one side of the board to the other. Some people are quite happy to probe, you know, like using meter probes like chopsticks, yeah, and come from either side of the board. I find this the easiest way, but you know, I mean, yes, it takes a few seconds to tag the wire on. Well, to me, it's the way to do it, yeah. So it comes through here somewhere. I can probably see if I look on the other side. There's two. No, of course they're under here. Of course they're under here now. And I can't easily see, but there was two places where it came through the board. Two vias, yeah, and I can see two vias up here. So I'm pretty certain it comes through on one of these. We can have a look. This is the advantage of having sharp meter probes, by the way, onto the green wire. Just see if we can actually, I'll do it through the microscope, it's easier for me. See if we can actually find where that actually goes to, yeah. That one, okay. So it goes to there. Does it go to any other resistors around here? I mean, I'm not interested in the capacitors as such, because the signal can't go through a capacitor. It doesn't go to there. I mean, you may have a capacitor on it. It's not unusual. I'll switch my meter back into continuity mode so it's not bleeping with diode junctions. Yeah, diode mode sometimes just gives up too many false positives. Yeah. Okay, so let me have a look around here and see where this signal actually goes to. Yeah. Guys, I had a look around on this. This is a bit of supposition. Basically, I can't see from this green wire going to anywhere else. Not directly, although I'm sure it does go somewhere, but I can't see where it goes to, is the truth. So what I did is, I started to trace from the other end, yeah, from the enable signal coming out of here, yeah, here. And what I found is, I can show you this as well. We'll go from by connecting to the white wire, yeah. So let's connect the meter to the white wire, yeah. So this white wire is soldered to the resistor that goes directly to the pin 1, the power grid, yeah. And what I found is, having a look around on the other side of the board, that white wire was soldered, comes through a via in the board and ends up here. You can see on the meter. I've turned the bleeper off, but you can see it's 0 ohms, yeah. And that ends up here. And here it looks like there's possibly a missing component. In fact, it looks like there might even be more than one missing component. But it looks to me like there's a missing component here, yeah. So I then had a look, thinking, okay, well, the green wire, the one on the base of the transistor, I couldn't find out where it goes to, yeah. Does it come to here? Okay, the other side of this missing component. And it doesn't directly, but it does come here through 10 kilo ohms, 9.95. So that suggests to me that this is connecting to, well, if it doesn't suggest, that tells me this point is connecting to that transistor via a 10k resistor, connecting to the base, and you'd expect there to be a resistor on the base of the transistor, yeah. So I'm thinking this might be where we're losing the signal, that this is obviously going high and obviously nothing happening here. So what I'm going to do is I'm going to stick a resistor in here. I'm going to put a 1k. I mean, I don't know what goes here at all, but I'm thinking, well, if it should be, this should be 0, and I've got, 0 plus 10 is 10. Me putting 1 plus 10 here isn't going to have a lot of effect. 11, yeah. And then this goes to another transistor here, yeah. It goes to here. Just get onto it. Does it go to, I think, yeah, it does. You can see the 10k. Here's another transistor here. So I'm just going to go ahead here and stick a 1k resistor in here and see what happens, yeah. Okay, so there's our resistor soldered, yeah. I still have the black lead on the white wire via this crocodile clip, yeah. So if we look now on the resistor we've just soldered in, this end goes to the green wire, yeah, which is the power grid, and this end, which you can pick up on the transistor now, goes to power grid via a 1k resistor, yeah. And then if we measure to the green wire, which is the enable on our other chip, yeah, we've now got 11k effectively, yeah. I didn't want to put a 0 ohm resistor in here because it goes to the collector of what looks like a transistor here, yeah. It goes to a collector, and you can assume, I'm just guessing that this transistor can turn on and ground the enable pin. I mean, this could be a 0 ohm resistor. In fact, if it doesn't work, if I'm not getting enough base voltage now on the transistor that turns the enable on, then I will try putting a 0 ohm in here. But anyway, that's what we've got in here. Let's have a quick look at the schematic and see what we've done. Here then, I couldn't find, this is where I had the green wire attached here, yeah, and I couldn't find where that went. I just could not find continuity to anywhere, though I'm sure it goes somewhere, yeah. So I started from the white wire at the other end. So what I have here this is pin 1, yeah, this is the P good signal, yeah. And I found that went to a pad on the board, yeah. It had a resistor, I'll put it right through P good, yeah. It had a resistor which is a pull-up 2.2k, I think it is. And I'm sure this goes to a positive supply, so it's like a pull-up resistor, yeah. And this went to a pad also where it completely looked like it was missing, yeah. Other side of the pad, this is the missing thing, but look, a few things might be missing. From here I found there was a resistance to the green wire of 10 kilo ohms, which suggests that there's a resistor in the circuit somewhere that I couldn't find. I couldn't find this end of the resistor, if you see what I mean. But from the green wire to here I read 10, yeah. Also from here is collector, or it could be a drain of another transistor, yeah, which I haven't traced, but that's what I have. So I'm kind of assuming that this obviously power goes high, but it's only high if this transistor is also switched off, yeah, because if it is switched off this will keep it low. I haven't checked this transistor, but we can look at it if we need to, yeah. But there seems to be a component missing here. So what I've done is here I've put a 1k resistor to make the circuit. That seems like a reasonable thing to do. I'm not sure I don't know if it's right, but it kind of makes sense. Yeah, can you see that makes sense? So let's have a look now to see if this transistor is turning on, yeah, which it needs to do. Okay, if it isn't, then let's have a look at this here to see. We know we've got high here, yeah, we've measured it. So let's see what we've got here is this transistor holding it off. I mean, if we're lucky, always lucky the right word, if our diagnosis is correct, this could well work. Okay, let's have a look. Moment of truth then, I guess. So I'll just attach the meter probe to the green wire, so I've got an extra hand free. So let's just this is going to be negative if I've connected the wrong lead, so it'll say minus, but that doesn't matter. This is the transistor base that we need to switch on. So let's power it up and see what happens. And it's turned on 0.6, but it still didn't detect. But I can feel the GPU getting warm now, and it wasn't. Well, do we have any VCore now? Let's have a look. Yeah, I'll just turn this thing over the other way up. So we've got 0.6 on the base of the transistor, which is exactly what we thought we should see if the transistor turned on, but it didn't detect. Let's put the power back on again. Okay, let's see now if we have any VCore or VRAM, yeah, because we didn't have before. So power up, yeah. What's on VCore? We've got VCore now. We've got VRAM now. Okay, why is this not detecting still? Why is this still not detecting? I mean, we fixed that problem, yeah, we've got the voltages. Okay, let's just try stick it straight into the computer without the extender, just to see if that makes any difference. Right, so I've put the graphics card straight into the computer, yeah. I'll just check. I mean, it's getting warm now, which you'd expect, yeah, because I've got VCore and VRAM, which I didn't have before. But it doesn't detect. No. These things can be infuriating sometimes. I mean, that was a good diagnosis, and we got the voltages there now. I mean, it's powering up now, but it's still not detecting. The first thing I'm just going to try, for my own sanity really here, is to stick this into another motherboard, just to see if it detects in that one. Just one error I made, not important, but let's correct it. So this isn't VCore and VMem up here. This is VCore and the voltage to the memory controller. And we're seeing 0.9, 0.9, 0.9 and 0.9. VRAM is actually over here and it's 1.5, yeah, as you'd expect. This is like not detecting, then giving one bleep, and this is the same as that R9390 is doing. That I fixed this again. I did a similar thing with that. Yeah, I've got the VRMs working, and then it just wouldn't detect, and it wasn't reading the BIOS. And I'm just starting to suspect there's some compatibility issue going with my dual core processor socket 775 board here. Although I have boards that do work in it. Yeah. So right, definitely going to try another motherboard on this and find something with a UEFI BIOS. I've connected this to another motherboard then, H97. This has UEFI BIOS, but it's not seeing the card. Basically the same as on the other PC, and I don't really know why I doubted it. Well, I mean, it's always worked before, but sometimes some funny things happen. Yeah, I'll just get the oscilloscope and I'll show you what I'm seeing with this one. Okay, so I'm just going to go on to the reset pin, which is pin 11. So you can probably just about see where I am there. Yeah, so that's pin 11, and then let's just start this up, and this should go high. Yeah, there, gone high. Yeah, so the reset's coming off. So there's no problem with that. The other place, obviously, of course, is the BIOS. So I'll just switch it back off again. One moment. Okay, power's off. Power's back on. So this is pin 1 on the BIOS chip, which is the enable pin. So let's have a quick look. So high. And it stays high, yeah. So this is another one that's just like all the, you know, the lights are on but no one's home, yeah. All the power's on but the GPU just doesn't respond. You know, a little bleep there, but that was the onboard video. It was nothing to do with this. Yeah, I've got a picture now from the onboard video. I've been into Windows and I can't see this at all. I run Specky as well and that didn't see it. It's just getting warm now as you'd expect. I've put the heatsink back on it. Maybe spend a little time just looking around the logic gate which is here. I'm not sure was there some 6-pin device. This is, I'm pretty sure, where the reset will come in. Maybe not. I'm just having a look to see if I can actually see where it goes. Yeah, might go up to here. So we can have a quick look at that on another video. But I mean, we've repaired it. Yeah, we've repaired the voltage rails. It just doesn't want to work. Yeah. Okay. I mean, I've took the heatsink back off, so I get it back under the microscope. Yeah. We can see here. This is the reset signal comes in here. Yeah, and it's going high. Now, if we follow this trace up here, it goes to some device here with a funny marking on it. Looks like it might just be damaged. Get some zoom in on further on that. Yeah, this thing here. I don't know if that is actually what kind of like burnt or if it's just how it is. Okay, what I'll do is I will go and ask. I'll take a photo of this. I'll have to go up onto Badcaps and see if we can tell me what this device actually is, because I don't understand the markings on this. Yeah, I'm guessing it's some sort of AND gate. It makes sense, you know, from where the input's coming in, or maybe a dual transistor or FET. It could be damaged, possibly, and that, if that's the case, that might explain why it doesn't work. It'll take me a little while to find this out. So what I'll do is I'll put this onto another video as I just mentioned. Okay, yeah. So as I say, I'll go see and find out what that actually is. Interesting to see what you guys think, whether that is actually damaged or not. Maybe somebody can even tell me on here what this actually is. Yeah. And I'll do this card, a final session, together with the R939 that also has the same sort of symptoms. You know, all the lights on but no one's home. Yeah. I've got a couple of urgent repairs to do tomorrow, so I'll upload this one today, and then I'll get onto the urgent repairs tomorrow, and then after that we'll come back. Hopefully I'll have some information on this, and yeah, let's have one final crank of the handle. Yeah, let's see if we can actually make this thing work. Okay guys, hope you enjoyed that one. I'm sure you learned something about tracing through the power logic, sequence logic. Anyway, is that power logic, sequence logic? Yeah, power sequence logic. Okay guys, ciao for now, see you soon.